So question 4 for the Edexcel Sample Assessment Materials, Paper 1, higher tier. We've got figure 4 shows 2 students investigating their reaction times. This is a classic experiment. Student B supports his left hand on a desk. Student A holds a ruler, so the bottom end of the ruler is between the finger and thumb of the student. When student A releases the ruler, student B catches the ruler as quickly as he can. The investigation is repeated with the right hand of student B. So this is a really common way of working out reaction time. You have a ruler, you hold it here, you drop it, and wherever you catch it, the further along the ruler that you catch it, the slower your reaction time is. So the students took 5 results for the left hand and 5 results for the right hand. Figure 5 shows them. Calculate the average distance drop for the right hand, give your answer correct to 2 significant figures. So the first thing to do whenever you're doing an average is look and see are there any obvious outliers, and here there aren't. 16.1 is 1 and a bit away from 17.5, 20.2 is less than 1 away from 19.4. I wouldn't call those outliers. So we're just going to use a normal sum for average, 17.5 plus 16.1 plus 19.4 plus 18.6 plus 20.2. Divide all of that by 1, 2, 3, 4, 5, and the average distance comes out as 18.36 centimetres, but it tells us to give it to 2 sig figs. That's 1, 2, 18. I don't need to round up because 3 6 would round down to 18. Then calculate the average time for the left hand using the equation they've given you. So time squared equals distance divided by 500. So I'm going to write t squared equals 18. That's completely wrong. They want to put the left hand. So 14 divided by 500. Now, I'm going to assume that I'm okay to use centimetres here because they've not told me any of the scales. So divide that by 500 and it comes out as 0.028. Do not write that as your answer. That is t squared. Really common that people forget to then square root it. T equals the square root of 0.028. And it comes out as 0.167 seconds. So 0.167 is my answer. Then we've got explain whether any of the readings are anomalous. So we discussed before here that none of these are anomalous, but let's look at the left hand. We've got 10.1, 25.5. These both seem pretty big. 18.4, 14.6, 11.7. So 10.1 is very close to 11.7, but 25.5 is not very close at all to 18.4. So I definitely say that 25.5 is an anomaly. And we need to explain why that is. So explain whether any of them are, which one is. 25.5 centimetres is, and why? Because it is much further away from the average which is 14 centimetres, than any other reading. And really, they shouldn't have included that in their average. So, what 2 ways can the students improve the quality of their data other than ignoring this anomalous result? Now, there's 2 ways to always do this. Take more readings with usually with a wider range. You can't really get a wider range here because it's just whatever you happen to catch it with. So take more readings. And the problem with this sometimes is you can't repeat an individual experiment because your reaction time will change over time, but you can get a repeat in that kind of mark if you have someone else measuring. So have 2 students take measurements is what the mark scheme says. I think this is a bit of a vague question, and I would hope that in the real exams they're a bit less vague than that, and they normally are. And then describe how the students could develop their investigation to investigate how reaction time changes within other variables. So right now they've just looked at what is reaction time, but how can they see if it changes within other variables? So first things first, you need to use a larger group of people. If you've only got 2 people, you're not going to compare anything. So use a larger group of people. Then measure reaction time of them all. And see how this varies with another variable such as height or age or anything else you can think of. So if you're doing it with all students in your class, you wouldn't want to do age because they're all the same age, but you might do it with height. But if you've got a group of people who aren't all in the same class, you might go for age and see if there's any correlation between the two.